All right. Hi, everybody. Welcome to the May 26th Seattle Spark Meetup. We've got an awesome session. Woohoo! First of all, we want to thank Tune, right? Because they are getting us drunk and they're feeding us. Isn't that awesome? Yay! Yay! All right, excellent. All right, cool. All right. So we have two really cool sessions. Basically, we have one on Spark Streaming. It's going to be demo heavy, so I'm not going to go too much. I'm going to do a little bit of slides, but I'm not going to go too heavy into it, so that way I won't bore you to death and you won't fall asleep, okay? And then there'll be an awesome session from Tune themselves about their Spark Streaming case study, okay? So we're going to do those two things. The first one's going to run about 30 minutes or so, 30 to 45 minutes, and I think Heather's going to do about 30 minutes or so. So you'll be out of here also relatively quickly too. So we won't make you fall asleep on any of this stuff, all right? For my session at least, you're more than welcome to ask questions. I might not know the answer to them, okay? So I want to be upfront about that, but you're more than welcome to ask a question, right? There also is a raffle. Hey, Felix, since you're the guy, why don't you tell everybody about the raffle? I will show the page. Yes. There we go. You got that?
It's going to be coming up here to Seattle on July 30th for a full-day workshop talking about Spark and TensorFlow and all these other things you see on the screen. It's crazy. So, and we're going to be raffling this out at the end of the session today. And so stay tuned. And if you still want a ticket, you can go to get the yellow one over on the reception here. And tell your friend, because we're going to be doing more in the next few meetup as well. So we're going to do one here, next one, June 3rd, you know about the next one coming up. But go to the next one as well. We're going to be talking about some exciting things, which Denny is going to do.
Thank you. Thank you very much, Felix, since I have no idea how that works. But the cool thing, though, is that we do want to call it that this is actually Chris Begley. He's a member of the Apache Spark community. He's a lot of fun. He's a bit of a crazy guy, but he's actually crazier than me, which is a little scary, okay? But he's a really smart guy, really knows his stuff, and I highly recommend his sessions, even though he technically works for IBM and I work for Databricks, so we're technically competing, but I don't care. He's a good guy, and his sessions are really cool, all right? So, all right, let's see, what else? Okay, upcoming sessions. We have the one on the 15th, June 15th at Extra Hop, also here in Seattle, okay? We're going to be focusing on highlights from Spark Summit San Francisco. That's actually June 6th to June 8th. I'm going to have a little blurb about that in a second. The highlights are specifically Spark 2.0. Okay, structured streaming, the faster APIs, the unified APIs, things like that. Okay, so if you guys want to know what we're doing with Spark 2.0, please do come to this session. Okay, so because that's where we intend to talk a lot about those features. All right, cool. All right, and then also on the 29th of June, we're going to go back to the east side at Microsoft for a Spark at Microsoft extravaganza. There we go. Okay, so basically it's going to be three really cool sessions. One on temporal operators for Spark Streaming. That's actually the Office 365 service. Spark on Yarn, and the 5 lessons learned in building streaming applications at Begley. Okay, so some really cool stuff there. They're also going to feed us really well too, so that's a good session as well for you guys, okay? So, a lot of cool sessions, and just like Felix noted, we're probably going to raffle off tickets for Chris's session then as well, okay? All right. We also have a July 28th session. We're actually going to go back to one a month because I think we're all really tired. So Spark at Zillow for real-time analytics, Spark, NiFi, Kafka, Cassandra, Elasticsearch, and Docker. So if you recognized the previous screen, which was this one, basically this is a longer version of this session because this is actually Chris Begley who's going to go ahead and do his abridged version of the pancake stack, and then if you're interested, you can go to his full session. Okay? Cool? And the final little spiel, logistics-wise, is that we have Spark Summit. So if you guys are interested, go. You can still register for Spark Summit. Okay, it's we have a Spark Seattle discount code that gives you 20% off. So if you guys are interested, we're going to be down there June 6th to June 8th. Okay, I'll be there too. So we'll be at the booth. If you got questions about Spark, please come on down. It won't just be me. It'll be people like Michael Armbrust, Matej Zaharia, Patrick Wendell, the people who actually really know the stuff. They're going to be there. We're going to answer a lot of cool questions. Okay? Cool. All right, then without further ado, I think we're going to go right into the session. So before I do that, I wanted to ask a question for everybody here, which is, who's actually familiar with Spark Streaming here? Raise your hands, please. Okay, cool. Who's actually put it into production? Okay, cool. All right. So for folks that have not placed it, for most of the folks here, we're going to go ahead and do a quick primer first. Okay, so like I said, I'm going to do some slides, and then I'm going to do some demos, and hopefully my demo won't break. Okay, so that's what we're going to go do. Like I said before, please ask questions. I might not know the answer, but please do ask them anyways. Okay. All right. So, oh right, I keep forgetting to always do this. Who am I? I'm one of the guys who helps organize the Seattle Spark Meetup. If you don't already know who I am, I used to be the Senior Director of Data Science Engineering at Concur. Prior to that, I was on the Project Isotope team, the team that actually brought Hadoop into Microsoft. And so currently I'm a technology evangelist at Databricks. I basically dance around and talk Spark. And I've been doing that for the last 4 years anyway, so why not just get paid to do it, right? All right, so what's my company? We are Databricks. We're the ones who, the creators of Apache Spark created Databricks back in 2013. 75% of the code base is of the Spark code base was contributed, the core code base, excuse me, was contributed by Databricks, okay? And so this is the one little spiel that I have, which is, what is Databricks? We bring value by going ahead and actually making running Spark a heck of a lot easier by placing a set of managed services and a managed platform on top of Spark, so that way you don't actually have to manage it, okay? That's my one spiel and I'm done. All right, cool. So this is a cool slide from our friends actually at the Washington, D.C. Area Interactive Spark Meetup. I really like it because the way she explains, like, if Spark was the Justice League, then basically the Spark Core API is basically Superman. Wonder Woman is the sequel Data Frames because she can do anything, okay? Spark Streaming is Flash because it's super fast. MLlib, of course, it's mainly because, it can go ahead and solve just about any known problem, and the Batman for GraphX just because, well, the guy is really smart, and when you look at graphs, it's actually about, it's almost like about neural networks, so it's a loose association, so I apologize for that one, but that's how we're gonna go do it, okay? So, before I go on, is everybody here familiar with Spark, so I can skip that section? Raise your hand if you know Spark. All right, good enough, all right. All right, sweet. Okay, I'm going to skip a bunch of stuff, and I'm going to go to Spark Streaming. All right, first things first, I'm going to do a quick version of the primer before I go into the demos, only because if you don't know Spark Streaming, I want to at least give you these quick contexts. There's actually a couple of really good sessions that I'm going to include in the slides, so you can go look at them, that actually go in much more detail. In fact, there actually was a productionizing your streaming jobs session that was just done this morning with Prakash Chakligan. He's a guy from Netflix who joined Databricks as a solution architect, so he actually knows a ton about Spark Streaming. And so the webinar is actually with him, so I would advise that if you want to go a little bit deeper, watch that webinar because actually there's a lot of good info in that session. Okay, so I'm only going to do a high level because I actually want to switch to demo as soon as I can. Okay, so Spark Streaming, what it is a scalable, fault-tolerant streaming processing system. Basically, what you're trying to do is you're trying to go ahead and have multiple sources. In this case, we've noticed things like Kafka, Flume, Kinesis, HDFS, Twitter, whatever else, to basically go into Spark Streaming so you have a fault-tolerant, exactly one semantics, so it ensures that you actually are processing the data, and you're getting the data, and you're able to store the data. You don't want to lose it. The power of Spark Streaming is not just the ability to do streaming, though. It's actually the ability to integrate with the rest of the Spark stack. So as you'll notice from the next session, the one that we're planning for June 16th at Extra Hop, we talk about how we are building structured streaming. So in other words, we're actually integrating data frames and streaming together. So that way it's even that much more powerful. The way Reynolds Zinn actually had described is the best way to think about streaming is to not think about streaming. Okay, in other words, most of everybody here, including myself, we're familiar with the idea of data frames or a table, right? So what's really streaming, structured streaming? It's really within the context of saying that on a table, the latency is really low. Okay, in other words, I can go super fast and be able to insert, update, and read data from that table. So that's the way structured streaming was built, with the idea that you can start thinking about your problem not between a streaming problem or an RDD problem, but simply as in, I've got a data frame and what latency do I want, okay? So this is the integration stuff that we're trying to do right now, and you're gonna hear a lot more about that in the next session. We can't talk too much about it yet because it's not public and we haven't even released 2.0 yet, but as soon as we release 2.0, we're gonna dive into that stuff, okay? So what you can use it for, there's some fun stuff like real-time fraud detection, reactive anomalies and sensors, IoT is the buzzword of the day, cat videos, yeah, there you go. If you want to go ahead and look at stuff in near real-time or real-time, this is what Spark Streaming is here for, okay? And the last slide I've got here is basically some quick highlights. Basically, Netflix, Uber, and Pinterest are three very large examples of where Spark Streaming has solved some massively large-scale problems, okay? And so basically, these are the guys that have pushed Spark Streaming to the next level. And so if you want to dig in, because I'm not going to do it here, but if you want to dig in, the slides that I'll send out actually will have links to all of these case studies. So that way you can dig into that, okay? All right, so now I'm going to go into actually just demoing stuff, all right? So let's do that. So, sorry, give me a second. I'm not going to send you guys this slide deck because this current slide deck is about 251 slides. So who wants to read that? No, you're lying. That's all you're doing. Okay. All right, so I'm going to go ahead and use a Meetup example. Why? Because we're in a Meetup. So I'm going to use a Meetup streaming example. Okay. So what do I mean? What do I mean by a Meetup streaming example? Okay. So if you go to the Meetup site, for those in the back, you probably can't see this very well, but basically, you all RSVP'd to this, right? At least I hope so, okay? And some of you declined and then we came back, but basically you clicked on a link to say, yes, I RSVP for this Meetup, okay? Well, in the case of Meetup.com, they have hundreds of thousands of transactions per second for all the meetups in the world. Okay? So it's a streaming scenario because when I want to do aggregations or analytics or even just to do a trigger of some type against that data, as in other words, once I hit my mark of 150 people, go ahead and do something with it, right? So the idea is that these are all different streaming scenarios. They can either involve ags or triggers. So Meetup is actually a very good example of what a streaming problem is. So I'm actually going to showcase a little bit about the streaming problem and showcase also the reason why, even though I'm not going to be able to dive too much into structured streaming itself yet, I can showcase why we did it, okay, why we're doing this stuff, and it'll be code, okay, so no problem on that part. Okay, so here's the code base, okay, I'm actually going to go switch to a notebook real soon, but the code base basically is this streaming context function, okay? Basically, streaming is built, right in its current form, is built on top of RDDs, okay? Resilient distributed data sets. So I'm going to go ahead and basically have a streaming context that I set up. It's running in seconds, okay, because we want this thing to be running really fast, okay? And I'm going to build a receiver. So this one here, Meetup Receiver, is basically a set of code that was written in Scala that I completely stole from GitHub, but don't worry, I actually attributed it properly, okay? That actually goes ahead and reads Meetup, the information from the Meetup RSVP API. Okay, so it's a standard API call, basically, all right? So now I want to go ahead and stream the sucker and read it, and basically, in this case, I want to put the data into this Meetup stream JSON table, okay? The only reason I called it that is because it literally is a JSON file when it comes in, so obviously when I read it, I'm going to put it into a data frame, so whether it's JSON or not, at that point, you don't care, but that's what the data is, okay? Everybody with me so far? Cool, all right, so let's go to the actual code. So what I have here, okay, this is Databricks Community Edition, and these notebooks will all be available. So everything I'm showing you, you're gonna have to give me a few more days though, because it's really messed up and I need to clean up the code that I wrote, okay? But these notebooks are all gonna be available for you, okay? So you'll be able to download and run this yourself, okay? So this is not private code at all, okay? Let me zoom in a little bit so you guys can see it a little bit better, okay? And so all of this gook, okay, basically is the Meetup streaming code, okay? So I already included the most important parts of it in this slide, okay? But basically, all of this can be shortened down to what I just showed you on the slide, okay? That's why I'm not gonna make you look at all that, okay? But basically now what I'm doing is that I'm reading using, excuse me, give me 1 second. This is the Meetup Receiver I was talking about, okay? This is the set of code that I'm using to read the Meetup RSVP API. It's actually quite long, okay? So hence I didn't want to make you go through it, all right? All right, but the basic function here is this part, okay? Which is basically, I'm going ahead and setting up the streaming context. I'm going to zoom in so you guys can see it in the back. Okay? Here's the streaming context that I'm setting up, okay? And I'm reading this API call. Okay, this is the HTTP stream.meetup.com to RSVPs. This is just the API call for me to read the meetup information. Okay? Cool. So far, so good. All right. Now it's actually, I've already started running this thing. Okay? So basically, if I go ahead and query the table here, okay? Remember I said I was putting the data into Meetup Stream JSON, okay? Basically, I run this query, you're going to see more data showing up here, okay? So this data changes because every second that I run this, there's new data that's going to show up. Sometimes there's nothing. Oh, there you go. Right now, it's reading this, okay? So as more Meetup RSVPs are coming through, I can just read the Meetup Stream table, okay? Pretty straightforward, pretty easy, okay? So when I look at the Spark UI, here's it running, okay? The most important aspect are these two things, the input rate and the scheduling delay, okay? So how I got here, just to let you know, okay, this is, even though I'm using Databricks, okay, this is all Apache Spark. I'm not doing anything that's specific to Databricks at all, okay? I'm just doing something that's just more, just because it's easier for me to present, and since I work for the company, well, guess what? So, all right, so all I did was click on View Spark UI, all right? I go here, it'll show up, there we go. All right, I click on streaming. Now this is the standard Spark UI, okay? That's all I'm showing here. And then basically here's the information that we want, okay? The input rate and the scheduling delay. Okay, so far it's good because we're processing 2 events per second. That's good. Nothing a 6 gigabyte small mini cluster can't handle. It's not even a cluster, it's a mini node, okay? That can handle. Scheduling delay is 0 milliseconds, so awesome. In other words, as soon as the data is coming in, I'm catching up, I'm processing it, I'm doing good. Okay, sweet. Everybody good with this? What I've done so far? What am I missing though? If anybody can guess, what am I missing when I did all this processing? Can anybody hazard a guess? Go for it. Sure. That's exactly it. No, that's exactly it. Your question's exactly right. So for everybody in the room, his question is, where is the data being persisted? It's not. Okay? None of the stuff I'm doing so far is being persisted. All I'm doing is processing the batches. It's coming in, but I have not persisted. Extremely good observation. All right, so why am I calling that out? Let me rerun this code, okay? Actually, I'm going to need to cancel it. Sorry, stop the context, so give me a second. All right, and I'm going to run this code, but this time, give me 1 second. All right. Even though I didn't show it, this is what's happening here, okay? I did register the Meetup Stream JSON table. That's the table that stores the information from the Meetup API, okay? But it's only that batch, only that 1 second batch. So in other words, the next second, the data disappears and it's replaced with new data. I want to persist that though, right? So I commented that out. So exactly to your point, Danny's question here, where did I persist? I commented it out. Why did I comment that out? Because, well, after all, if I'm doing streaming, I would love to just store the stuff. So what is this query that I have here? All I did was simply say, well, insert into this bigger table called Meetup Stream all the data that I got from that little batch. Remember, the Meetup Stream JSON is the 1 second batch. It gets truncated and replaced, and a new 1 second batch, and there's new information, okay? Now I'm going to put it into Meetup Stream. Can anybody guess why this was a dumbass idea?
Latency. You have high latency.
That is correct. I have high latency. But why do I have high latency? Can anybody guess? I'm sorry? Asynchronous is sort of correct. but I'm actually looking for something a little bit more specific. The latency part has to do with it, but may not be as obvious. Go ahead, please. That is absolutely the closest part. Oh, you almost got it, but that's close enough. So I wish I had a prize to give. Okay, exactly. That's exactly right. The latency of writing it to disk. Okay, I'm inserting into a table, except this table, its back end, like a Hive table, right? Spark SQL table, is writing to S3. Now, does everybody think that writing to S3 is super fast? Right, exactly. It's dumbass slow. Okay, so why am I calling that out? Okay, so hopefully this code is running. I think it is, at least. Okay, so no, wait, good, perfect, okay. So I'm gonna run this right now. Okay, so that's the Meetup JSON. This is the one that changes every second or so, okay? So you notice that the data is changing with it, okay? But if I query the bigger table, Upstream, this thing just gets bigger and bigger and bigger, okay? So it's really cool. Now, why do I wanna do this? Well, because I want to do some cool reporting, right? I want to see over time what's happening to what's happening, okay? In terms of aggregations of all the meetups by country, let's just say, okay? That's a really cool calculation for me to make. Problem with that statement, though, is let me look at the UI again. I'll go back to So I'll go back to streaming. There you go. Notice this thing going up. And if I keep clicking it, it's going to keep going up and keep going up and keep going up. Notice the schedule delay is 31 seconds and 37 milliseconds. Okay? So this thing is getting worse and worse and worse. And I'm going to keep clicking it and I'll keep running it. At some point, I have to stop it because otherwise my cluster is going to crash. Okay? That's what's going to happen. Now, its delay is 37 seconds and 958 milliseconds. So often when we hear and talk about Spark streaming, we talk about the fact that the scheduling delay better be smaller than the batch. Remember, in the beginning I said the batch was 1 second. So, if it's 1 second, I sure as hell better be processing data faster than 1 second. Otherwise, I'm queuing everything up, right? So, though I'm storing all this data into S3, into this cool table, guess what? I'm delaying, and actually I'm going to stop it now because I'm going to crash the cluster. Seriously, this thing will crash at some point, okay? So, let me go ahead and stop it now. All right, so what should I do if I want to go ahead and do an aggregate like this, okay? But I don't want to go ahead and have the system crash it, okay? Go ahead. No, go for it. Okay, no, actually a very good question. Okay, so how did I write this to S3? Okay, so going back to the code real quick. Okay, give me a second, I'm going to comment so I remember to comment it out, okay? Remember how I went ahead and, where are you? Here we go. This is this code here, okay? This is the part that says SQL context.SQL, insert into Meetup stream, select star from Meetup stream JSON, okay? That's what I'm doing, okay? Insert to Meetup stream. Meetup stream is a data frame / table, right? Everybody with me so far? Cool, all right. Where is that table persisted typically when you're using AWS? S3. In other words, I set it up to be persisting in S3. Now, if I set this thing up to persist in some other system, maybe I would have been faster. But the problem is that typically in order for this to work, I'd have to persist into memory. That's the only way for this to work, okay? Because that would be fast enough for the writes to go through, okay? But because I'm actually writing to S3, and don't forget, S3 itself, when I write to disk, it replicates. When it finishes replicating to 3 different locations, then the transaction finished. Okay? So there's that latency that goes in. That's why we talk about, when we talk about S3 and other cloud storage, that's why we talk about eventually consistent, right? That's where the scheduling delay is coming from. Because S3 inherently is an eventually consistent system, not a consistent system right from the get-go. Okay? So that's the reason why you're seeing that delay. So how do I figure this out in memory? Okay, now, before I jump into the current way of RDDs, which basically is what we're doing is a concept called map with state. Okay, I'm going to show you the code for that, and I'm going to show you some cool graphs that go with it. Okay, ultimately this is the reason why we built structured streaming. Okay, because in essence, what we want to do is have you be able to do this anyways, and not know underneath whether it's writing to S3, writing to RDDs, writing to in-memory data frame, or any of that stuff. Ultimately, that's the purpose. So this one line of code, that's the reason why we're building structured streaming, okay? Because if you can go ahead and treat your batches of stream data like you're just treating a table, everybody here knows SQL, right? A little bit of it at least, right? You don't have to be an ANSI 92 compliant person. I'm just saying, everybody here knows SQL, right? So since everybody knows SQL, then if you know SQL and we can build structured streaming, then you already have the skill set to be able to do streaming. Okay? So that's ultimately the reason why 2.0 is about structured streaming. Okay? That's cool? All right, yes?
You still need to care.
I'm sorry?
You still need to care, right? I mean, you still need to tweak it a little bit until you can figure out, because at some point it's going to happen.
Yes, okay. So the implication I'm saying is that you still need to care, of course. Why? Because we haven't solved, we're smart, we're not that smart. We can't solve everything. There's still an operational aspect, okay? So I apologize, but I'm gonna do one little small Databricks spiel, that's the whole reason why we have Databricks, because we build a managed service to basically help auto-configure everything for you so you don't have to think about it, all right? But if you're not doing that, that's fine. I'm not trying to force you to use it. I'm just simply saying that in the end, there are still things from an operational perspective you have to care about. In other words, if you are writing to a structured stream, maybe we can make it significantly faster because you're writing to an RDD or a data frame in memory. That's awesome, but it's still going to fill up memory, right? At some point, it's going to fill up, and then all of a sudden, you're out of memory. How do you page the disk, okay? Do you need to still set up Zookeeper so you can actually ensure the transactions are in sync and then they're in the proper order so you're not getting data out of order when you're putting this stuff in? Absolutely. Everything you're implying is absolutely still the same. The whole purpose is that we're trying to figure out ways to abstract more of it away and simplify it for you. And that's the reason for structured streaming, because we're trying to figure out how to not make you an RDD expert. Okay? And so the analogy I like using, and then we started using this more often, is that if you think of Spark as code, RDDs is the assembly language. Okay? And data frames will be, I guess, the closest I can say would be sort of like, C. All right? Using that particular analogy. All right? In other words, I don't want to use .NET or Scala yet from this person's analogy, because frankly, even with data frames, there's still a lot of stuff you got to do, right? After all, you still have to write a bunch of Scala code, for John's sake, or Python code. Sorry, guy, to say that, okay? You still have to write a bunch of code, right? So in other words, you can't get away with just one SQL statement and everything works perfectly fine, okay? But the idea basically is that as time progresses, we're not getting rid of RDDs. RDDs is still a fundamental component of what you're going to do, but we're hoping that the abstraction layer of data frames, whether it's standard data frames or structured streaming data frames, will basically make it easier so you don't have to write assembly. Okay? Make sense? Yes, back there.
Say that it's stream-oriented programming?
I would not, it's a good question. So is it basically saying it's stream-oriented programming? And I would actually hesitate to say no. Not because it doesn't have the capacity to do it though. The reason I say no is because we're coming from the angle that most people understand SQL, right? As opposed to most people understand streaming. So what we're actually doing is most streaming systems, what they're trying to do is they're trying to put SQL syntax on top of streaming. What we're trying to do is we're trying to say, you don't actually have to differentiate with the SQL syntax that you're writing. The only differentiation you're doing is to understand the difference between the latency that you desire. Is your latency 500 milliseconds, or is your latency 5 hours, right? Traditional batching is 5 hours or 2 hours, right? That's what batching basically is, okay? Traditional streaming is 500 milliseconds, 50 milliseconds, okay? So what we're saying is that you can just think of it from a standpoint of data frames, just what latency you're playing with, and that's it. Okay, I know it's a semantical difference, but since you brought up a semantical part in the first place, that's how we're going to go for it. But we like calling out that difference mainly because it allows you to. Reynolds actually had a great way. I think I said this already, but it's back to what Reynolds said: is that the best way to think about streaming is to not think about streaming. So what we're trying to do is make you not think about it, basically. I hope that makes sense. Sweet. Okay. I thought there was another question here. Yes.
Roundabout question. When you think of SQL,
Correct.
how
Great question. Okay, so I'm going to, Felix time me so I don't talk longer than 2 minutes because I like talking about this topic. All right, so the question was, when I talk about SQL, in the SQL relational database world, there is the talk about consistency, specifically ACID compliance. And I'm going to stop myself there because I'm going to go into analogies, okay? But the context here is that when you have ACID compliance, you can trust that the transaction that just happened will get in, and you know it. Everything I'm talking about here will never meet that criteria, period. Okay, let's go on. So the reason for me talking about SQL isn't about ACID compliance at all. Okay, the reason I talk about SQL is simply the language and the AST that goes with it. That's it. Okay, in terms of you wanting to, because after all, what is Spark? Spark is an analytics platform. Being an analytics platform, we can go with base. In other words, eventually consistent. It's perfectly fine for us to do that. Now, some of you are going to say, but yeah, I've got transaction systems. I need ACID compliance. Fair enough. Spark's not it, and never will be it. Okay. There are cool projects like Kudu, okay, that are out, which is basically built on top of HBase, that actually allow for I shouldn't say allow for it, but are closer to it for that type of consistency. Okay. The folks that are building Tachyon, which they changed their name and I forget how to say it. So, but those guys, in terms of the in-memory file system, that's closer to that. Not quite ACID compliance, but closer to it. True ACID compliance still results in a database. So that's why Oracle, that's why SQL Server, that's why MySQL are still going to be around, because there are going to be specific scenarios where you can't compensate for the lack of ACID compliance. Okay? But there are a lot more scenarios where your premise, almost done, thank you. Your premise or thought process about ACID compliance is actually not required. In other words, we needed ACID compliance for relational databases for transactional purposes. That's what we need it for. But there are far more use cases that look ACID, but actually aren't. And so that's what I'm saying, that for systems like Kudu or whatever, or HBase or whatever else, they can actually fulfill that. Back to Spark, so I can finish this. Yeah, Spark is an analytics system, so it's not designed for that purpose. It's never meant to be designed. In fact, if you're talking about transactional consistency, this is the reason why you have Cassandra or S3 or anything else underneath it, because that's the storage system you're going to do, and that's the thing that's going to guarantee your consistency. Fair enough? Okay. I apologize, I went completely off course, but it's a cool topic. So, all right. So now, I said that in order to do the same thing, I'm going to do a map with state instead. Okay, so let me go run that, and hopefully my code doesn't break this one, because like I said, I just started messing with the code recently, so we'll find out. Okay. All right, so same code. I'm going to run it right now, and I'll show you the slide version of it, because it's all right. Okay, so update map with state. So here's the basic functions. Here, okay, in this one slide, okay? Again, lots of code, lots of fun, but the basic premise is that there's a track state function, in other words, so you can maintain state of the data, okay? In other words, what do I mean by state? In other words, if you are storing, let's just say, meetup counts, RSVPs, okay, by country. So I'm gonna say Canada 1, US 2, okay, just like that, okay? Well then, when I want to go ahead and do an additive aggregate function, in other words, another batch comes in that says Canada 3, I don't want to replace Canada with Canada 3, right? I want to go ahead and say, oh, Canada was 1, add 3, now it's 4. That's state, okay? It's a simpler version of it, but that's basically what state is, okay? All right, so this is what that function does. Same streaming, same receiver, exact same code. Okay, no other changes there. And here's the other part, which is to say, you're going to go ahead and run the map with state. This is this function right here, okay, in order to execute the aggregation. Okay, that's the basic principles. All right, so I'm going to go back to the code now. All right, so again, hopefully this code works. All right, so far so good. So if I look at the batch meetup stream country, right, I will run it. Right now it says US 0, Canada 0. Run it again. Cool. Already, US is 105, Canada 11, so forth, so forth. Run it again. It's building up, right? Okay, at least I think it is. Let's go ahead and look at the UI. Cool. All right. There you go. Okay. So here's the schedule. Oh, sorry, I just skipped a little higher. Here we go. Input rate 1.83 events per second. But the important part, scheduling delay 632 milliseconds. Okay, below the 1 second size. I don't mind the number being a little high. The reason I don't mind the number being high is because I'm using Databricks Community Edition to run this. Okay, so this is not what I would call a production cluster by any stretch of the imagination. Great for learning code, great for running stuff, but it's under the 1 second mark that we want. And in fact, it wouldn't surprise me if as things go on, it's going to go a little bit faster. Okay, so let's just run it again. There we go. Now it's dropping down to 545. Okay, sweet. All right, so what else can we do with that? Well, this part is going to be a bit more Databricks specific just because we've got visualizations in hand. So I'm going to just go show those real quick. All right, where are you? Cool. Sorry. And so here is the table that I'm talking about. So this is the table that is batching up all the aggregates. So over time, these numbers should increase. Okay. I'm going to run all mainly because. See, now it's jumped up to 248, okay? But then what I like showing is this one. Oh, darn it, there you go. So basically, as time progresses, this chart will change, okay? And you can run a dashboard that basically tracks all this stuff. So that's the purpose with map state. The whole purpose is that way, as time is progressing, you can aggregate your values extremely fast. There won't be any delay. At some point, which admittedly enough, I didn't finish writing the code for it, so I'm not going to run it because it doesn't exist yet. I'm going to go ahead and tell the code to persist to disk. In other words, insert into a final table. Okay? And at that point, what we want to do is we're going to join those two sets of tables together. You have the current table that's constantly fluxing data in, and you have the historical data, okay, for that table. Okay? That table might be slower, but that's okay because typically we're just aggregating a historical table with a current table together. Okay? That's the idea. It's an old school database trick basically. It's exactly applied in very much the same way here. Okay? So in the end, that's why you actually care about map with state because by being able to do that, now you're able to go ahead and actually do the global ags that you care about. Okay? And then the last part that I want to just finish off with is, like I said, is that with Spark 2.0, you're gonna start seeing structured streaming handling more of these things. So the context that I just gave you, map with state, in fact, may not even be necessary. Now, not be necessary from development purposes. Obviously, 2.0 is just coming out. I'm not going to say it's prod ready because it ain't. Okay, we're going to try to make it prod ready, obviously, but the reality is that once we release it, we're going to be testing the living daylights out of it in our own environments. Other people are going to do the exact same thing. We're going to make the various fixes. After all, this is an open source technology. Okay, but the idea is that how Netflix, how Pinterest, how Uber, how a lot of these companies operate right now when they're running Spark streaming, that's how they're doing. They're using map with state. Okay? Cool. And I think that is it for me. Right. I'm literally going to end with this. This is Reynolds' little thing. I've already repeated, so I'm not going to stop about it. And so the final call out about that we're going to dive a little bit more into it for the next session is that when it comes to 2.0, you've got a high-level streaming API built on top of the Spark SQL engine. Runs the same queries as on data frames as you would traditionally do, so you don't actually have to differentiate between your streaming query and your batch query, okay? And basically all the things that you care about, like event timing, windowing, sessions, all that stuff is all embedded with 2.0, okay? And the most important aspect is this part, which is it unifies the streaming, interactive, and batch query mechanisms. So that makes it your life easier because it goes back to what I was talking about in the beginning. When you're looking at the problem, you're just looking at it from not a SQL perspective versus Python Scala perspective, but just simply purely from a latency perspective. Is it streaming? Is it interactive? Is it batch? Okay? And that should do it for me, guys. Yeah, any questions? Please. Excellent question. Okay, so the question is for everybody here, does the Spark SQL code base, Spark SQL itself, does it support all the functions that are typically available in relational databases like MySQL? And the answer is no, okay? It has a lot of it. We basically follow the HiveQL specification, okay? Basically, whatever is available in Spark SQL follows whatever is available in HiveQL, all right? And HiveQL basically is a general rule of thumb about 75% compliant to NC 92, all right? But the good news is that every single database is only somewhere between 75 to 95% compliant as it is anyways. MySQL happens to be one of the better ones, but actually most other databases are not NC 92 compliant anyways. So how that affects you is basically this. You're not going to get all the functions that you're used to, okay? But usually those are very specific end cases, or corner cases, excuse me. For the vast majority of the cases that are available, most of them are available already in HiveQL/Spark SQL. And so I can tell you that from my experiences from working at Concur, working at Microsoft before, I used to work for the SQL Server team. So basically, the way I guess I can explain is that not once have I written a UDF to cover for a function that wasn't available in SQL Server. Basically, not once. I mean, there was one time maybe I was trying to avoid it because I hate writing UDFs anyways, but as a general statement, there wasn't a single one that I actually needed to write. So most of the functionality is there, basically. But yeah, there are going to be gaps, definitely. Yes?
Are you going to provide a latest Apache renderer for Spark as well, or when it's available?
We're still debating on the Apache Beam stuff, actually. The reason why isn't because we don't like Apache Beam. Quite the opposite, actually, because right now, most of the asks from the community, this isn't a Databricks thing, this is a community thing. Interesting enough, it has actually been more on the TensorFlow side, not on the Beam side. I realize that the two have nothing to do with each other, like one's streaming, one's machine learning, but from an integration perspective, we've been getting much more requests on the TensorFlow side of things than on the Beam side of things. This is definitely something we're definitely looking at, though. So in other words, I'm not trying to knock it. It's just one of those things where I don't think there's been enough community voice that's been asking for us to do that. So what I would advise is that if that's something that's super interesting to you, go look for the JIRAs and upvote them, right? Because that's all we do. It's not like we're actually doing anything specific. We might try to help or guide some of the stuff that's happening, but overall, all we're doing is looking at the JIRAs and figuring out what's most interesting. So, I believe there is a Spark package coming out in the next 3 weeks for Beam. I believe there is, but mainly because it was one of the developers I happen to know who works on Beam was working on it, but I don't know the state right now, so that I can't tell. So, yeah. Cool. Yes? No, it's like, no, don't worry.
So you're mentioning the map state, which is the Spark data are very set up data.
Correct.
And when you store the data, you can put it into the disk.
Correct.
That's where you have to read. So when I'm querying the data, which is the fact data and the historical data, does the SQL team access for the functionality like sorting by all of Spark, both the track data and the historical data, or rather to coding and counting?
No, you're absolutely right. So the current state is basically this, okay? So I'm going to actually repeat the question in a slightly different way, okay? But it's a completely dead on, okay? Map with state lets me go ahead and write to disk. Write to keep the ags in memory. Whoa, that was wrong. Keep the ags in memory, okay? All right, now, what's the problem with that? Well, at some point I put a timeout on map with state. So in other words, once I say an hour timeout, guess what? When it's after an hour and I haven't seen Canada come in anymore, what's going to do? The code in its current form, because I was lazy, will break, okay? So what am I supposed to actually do? The map state code will actually say, no, if I don't see it, I'm supposed to go ahead and take the historical data, write it to disk, and then continue on and continue aggregating. That's what it's supposed to do, okay? So what does that mean, though? It means what you're implying, which is even if I put everything into a data frame, okay, in its current form, it means that I have two data frames. I have a historical data frame, and I have a current data frame. Now the good news is that I should just be able to write a SQL query and query both of them. The bad news is the views suck still. So in other words, what's supposed to happen is I could write a view to it, and then the view actually points to both data frames, and I'm good. That's what's supposed to happen. It doesn't work. Okay, so we're fixing that for 2.0. Okay. What's also happening with 2.0 is the ability that we will be able to do that automatically for you. So the data frame view, in essence, actually will go to two different constructs, and you're not actually aware of that fact, and that's perfectly cool. Okay? Well, I mean, you can still find out, by the way. We're not hiding that much. I'm just saying we're abstracting that stuff away from you. Okay? Okay, cool. Danny, you have a question, I think? And then probably edit it so that way Heather and Co can present. Yes. Oh, okay, sorry. So basically what map, no, it's a great question. What map with state basically does is says, it's basically designed for the purposes of aggregations, of doing global aggregations. And what you're doing is that you're writing the aggregate. So in other words, remember I said first it was Canada 1, okay? A new batch comes in, okay? Sorry, a new micro batch, right? Because it just read the JSON, but now it's Canada 3. I don't want to store Canada 3 anymore, right? I want to store Canada 4. Okay? So what map with state does is that it allows me to do that aggregate. And the actual function is not map with state by itself, right? Map with state basically says, I'm putting information in memory, and the actual function does the actual addition itself, obviously. So in other words, you can do other types of aggregations, okay? So it's not like map with state, all you do is additions, okay? I'm saying map with state is to keep it. Why do you care about that is because map with state is a distributed system. It's not like, it's easy to write one that's just for a single box. It's hard to write one that's actually meant for a distributed environment. And that's what map with state does for you. Okay? Cool. All right, well, if you have any questions, don't hesitate to ping me. Otherwise than that, I'd like to hand the floor to Heather, okay?
So my name is Heather Wade, and I'm the dev manager here at Tune. I work on the Tune Marketing Console product. I'll talk a little bit about that in a second. And today I'm going to talk to you about a few of the use cases that Tune has approached with Spark Streaming and Spark. So here at Tune, we have a mission statement, and that is inventing the future of marketing technology that is people-centric, fully connected with advertising, and that unifies the industry through a Wallace garden. I think the main point of this that I want you guys to take away with right now is that we're very marketing-centric. We have two main products in our business. One is the Has Offers product, which I'm not really going to be speaking about tonight, but essentially it's a white label affiliate network platform. So if you want to run an ad network or an affiliate network, you could do so completely on the Has Offers technology stack. The other product that we have is the Tune Marketing Console, and that is the product that I work on. And essentially the Tune Marketing Console is a suite of tools for marketers, as well as a mobile analytics product. So there's really four main features that we have in the Tune Marketing Console. We have Attribution Analytics, which is what I'm going to primarily be speaking about tonight. And essentially the purpose of Attribution Analytics is to track how users are coming to your mobile app and how they're interacting with your mobile app. We also have in-app marketing. So if you have a mobile app and you have a user base, in-app marketing allows you to really engage with your users the best way possible. We also have App Store Analytics, which is sort of like SEO, but for app stores, helping marketers optimize their app store pages. And then we have Tune BI, which is like a BI suite that sits on top of our other products. And I borrowed this slide from our great marketing team who loves to make graphics. And essentially, it just describes how all of the pieces fit together. This isn't really quite readable, but essentially what the Tune Marketing Console is trying to do is lead the marketer through the entire customer's journey in one integrated solution. And one of the ways that we do that is through the Attribution Analytics product. So in Attribution Analytics, we are measuring tens of billions of events per month, around 50,000 RPS at peak, and our pipelines process about 240 megabytes per second. So many of those events come from ad networks in the form of ad clicks and impressions, so representing end users' interactions with ads when they see them. So our customers, the people who actually pay us money, are app marketers, and what they do to use our product is they integrate our SDK into their mobile app before shipping it off to the app stores. And then once customers start downloading their app and using it, the Tune SDK collects data about how users are engaging with the app and then sends that off to our ingestion endpoints. And our ability to automate this process at a huge global scale is unbelievable and unlocks incredible potential for Tune customers in how they can leverage their data. So this chart actually represents a few different interactions that bring users to an app that we do measure, which would be, for example, a user clicking on an ad in a mobile web browser and then landing either in the App Store to download the app, or deep linking into the mobile app itself, or perhaps landing on a mobile web version of that app. We also measure the same thing for desktop web as well, so it's not strictly just for mobile apps, although that has been our primary focus. So our team processes this data and stores it for downstream consumers, like our reporting team, who build visualizations like this to deliver insights that help marketers make better decisions about their marketing efforts, whether it's which ad networks are they going to give their marketing spend, or what other marketing opportunities will help them engage with their users. Our data teams, which are the measurement and the data infrastructure teams, are centralized around complete solutions for our data, from ingestion to ETL and storage and archival. And the data that we're processing has relatively high cardinality and includes device, geolocation, and other data that provides high value for our customers or the marketers of these apps. And they're using this data to both acquire new users through different marketing channels, as well as trying to maximize the value of their existing customers. And for Tune's customers, our ability to solve these data problems in real time is really crystal clear around the benefits that offers to our customers. So the use cases that I'm going to cover tonight are really some pretty basic and straightforward use cases for Spark and Spark streaming. And I'm going to talk a little bit about our motivation for wanting to make these changes to our data pipelines. One is to address scaling issues as we've grown. I mean, our data that we're processing is growing exponentially. We also wanted to address concerns that we had around data breakage and data repairs. Previously, we were archiving our data and storing it in JSON, and it was unstructured. So if we had different data quality issues or schema changes from upstream or downstream components, it caused a lot of problems for us. Also, we have had a lot of inconsistency in latency. So we had several data flow pipelines that were feeding data sources that were being consumed by data consumers downstream. And these processed at different rates. And what that means to our customers is a really poor user experience when, if the data isn't really being processed at the same rate. As a customer, I'm looking at one report and the numbers don't match the other reports. So that's kind of a problem that we're trying to solve broadly. Again, related to the data breakage, we also wanted to introduce contracts between consumers and producers of data, as well as lower our costs all around, and provide common abstractions for dealing with data and streaming issues. So the projects that I'm going to discuss today, or the use cases, represent just the beginning of our journey with Spark. This is a very exciting time for us here at Tune. And we're very invested in the Spark project and are really beginning to see the benefits of using Spark in our production ETL pipeline. And with the success of these projects, we're now moving on to looking at more complex use cases for our next generation of features. So the two use cases that I'm going to talk about tonight are our new archiver and our stats batcher pipelines. We're also using Spark for our audience segmentation features, which I'm not going to cover tonight. But Alfred Cam is in our audience somewhere, and he is an engineer on that project. So if you're interested in that, definitely hit him up after the talk. So for our archiver project, we basically replaced our data archival system with Spark streaming. And some of the problems that we were trying to solve were the data breakage that I mentioned earlier. Now our data is being persisted in a strongly typed manner that adds a contract between the different teams that are accessing the data or that we're ingesting the data from. It also allows us to more easily accommodate our data retention requirements, which we incorporated in our sharding strategy to make that easier. And that also allows us to more easily accommodate data repairs when the need to do that arises. So over here on the left, this box that's labeled measurement, that represents the upstream data ingestion systems, which is really outside of the components for the data flow team. And what they do is they send all of the events to a Kafka topic, which I've abbreviated as PMR. It stands for prod measured raw. Essentially, it means that it's all of the data that's been measured and is ready for archival or further processing. So the first component that we have for Spark streaming is the flat buffer converter. And what that's doing is just batching the data to a 5-minute window, converting to a flat buffer array, and sending to the flat buffer raw log topic, which is that FBR topic on the bottom. There are two other queues or two other Kafka topics that are mentioned up here. One of them is the flat buffer delinquent file, which I will talk about in a second. Oh, actually, yeah. And the dead letter JSON. So that would be where any error files go. So the flat buffer delinquent file exists because most of our events, like 99.9% of the data that we're processing, we receive within 3 days of when it actually happened. And in order to batch efficiently, if we receive an event after that time, we put it in a separate topic and it's processed separately. And that actually has its own pipeline that's not displayed here. One of the reasons why we used Spark streaming instead of batch is due to the nature that this data is constantly arriving out of order, which can be a problem for batch processing. So essentially, we have used Spark streaming to accommodate for that. And it arrives out of order for a lot of different reasons, but one of the big ones being that our SDK can only send those events to our data ingestion endpoints when the phone is on and the app is open and it's connected to a network connection, right? So if a user completes a bunch of activities and then closes their phone, they come back later, we receive those events out of order, and that's one of the reasons why we have this problem that we have to deal with. So after that, it places those on the flat buffer raw log topic, and then we have another component which is on the other side of those Kafka topics called the flat buffer archiver. So the flat buffer archiver is a Kafka consumer, and we used the receiverless direct approach primarily because we're very interested in this process. This is archiving all of our raw log data in having an exactly once semantic. So using the receiver approach, essentially your Kafka is you're using Kafka's high-level API to store the consumers that are offset by Zookeeper. And that definitely ensures zero data loss, but there's a chance that some of those records may get consumed twice under some failure conditions. So in this case, we're not doing that. We actually are using a simple Kafka API that does not use Zookeeper at all. And this helps us eliminate any inconsistencies between Spark streaming and Zookeeper and Kafka. And that makes sure that every record is received and processed exactly one time. And the reason why that's important for us is because this is our data archive. So we need it to be accurate, we need it to be right. All right, the next project that we've done, or the next use case, is our stat bashers. And here I have a diagram of our legacy stat bashers. Essentially, this is, again, placing the events onto a queue. It's really a series of queues. And the stat bashers are consuming those, placing them into a temporary S3 bucket, sending another message to another queue. We have a second level of processing, and that's being stored in S3. And then downstream, some loaders are pulling those files out of S3 and loading them into data stores. We have two different data stores here. These are TuneDB, which is a columnar data store that's based on InfiniDB that we use here at Tune. And essentially, these two data stores are used by different data consumers for handling different use cases, and they have different SLAs. So that's why we split them up at the end. So when we went about recreating this batching process using Spark streaming, it's really pretty simple. We are using the same Kafka topic that we were using for our archival process, and we have two different Spark streaming clusters that are consuming from Kafka and doing pretty simple aggregations on various fields that are in our raw logs. And then we're using AWS Lambda to send a message. We're using AWS Lambda to send those to our loaders that are then loading the different TuneDB stores. So again, this is a really basic and straightforward use case. We're currently in the process of productionizing them. So if you want to hear a little bit more about some of the challenges that we were facing in productionizing them, definitely hit us up after the talk. So essentially, Databricks was, we used Databricks in developing these solutions, these initial use cases, and it really was a great fit for developing against these use cases. It was really able to let us get going quickly. We reduced a lot of overhead in working with ops teams on acquiring the clusters, tuning the clusters, and so that was a really fantastic experience to use Databricks. Now where we're looking to go next is really at replacing our other MapReduce pipelines, as well as applying Spark for different ad hoc analysis use cases that we have, which so far Databricks has been a really great product for us. As well as using Spark for research and development for our next generation of features. I do also want to add that our team is hiring. So if anybody's interested in talking to us, we also have David Elliott here from our team as well, and we'd love to talk to you.